Okay, so now, cloud builders, it's time for Fireside chat. Meet my colleague, Nicolai Parlog, Java champion, Java developer advocate at Oracle, and organizer of Ascento conference. He also writes, speaks, streams, trains, and consults about Java. Nikolai will be holding the Fireside chat on the topic Modern Java in format of Ask Me Anything. So you can ask Nikolai about new Java features, Java release cadence, migrations, Java futures, particularly Project Ember, Panama, Valhalla, Loom, and so on. So prepare your question for Nikolai and ask them in Slido. Here, link is here. Welcome, Nikolai.
Hi,
Glad
Jim.
to
Thank
see
you
you
for the
here.
introduction. Thank you.
I also should mention about the safe harbor that we do not represent Oracle company here in any way. So all meaning statements and assumptions are just my and maybe your personal stuff. So it shouldn't be treated as any commitments.
Yeah, that's how we can really tell that we work for Oracle. We have to say that. Funny story about working for Oracle. So Artyom and I, we got to know each other like yesterday. So yes, we work for the same company, but it's a big one, and we didn't
Yeah,
meet it before.
yeah, we
I
didn't
think it was
met
the day
before,
before,
but
actually, right? It was Tuesday. Yeah.
I propose to start talking about modern and sexy Java. So let's start with some introduction. Maybe you can express your opinion about what does modern Java states for.
Yeah, so
What is
I mean,
modern?
Java is quite a long and a history that had its ups and downs, and I think specifically after Java 7 came out, uh, like it took a while for Java 8 to materialize, and 6 and 7 didn't have the biggest changes, and Java. I think people have been proclaiming Java dead probably since the 2000s began, but during that time, after during 6 and 7, I think they had the best arguments, and so really like Java didn't do very well. And then I think the big change was really Java 8 with lambdas. It's not like like it's obviously not the biggest innovation. Other languages have lambdas, but Java showed that yes, it can evolve and it can pick up new features that are needed nowadays, that people need to write modern code, where you would not need like anonymous classes or tons of implementation classes somewhere for all your listeners, all your strategy patterns, where you could very simply just create some functionality in line and pass it on to an API like the Stream API, for example. And Java 8 saw great adoption. Like people really liked it, and it was a phenomenal release. And then came the necessary restructuring of the undergrowth, I think. So with the module system, they went to Java 9, and a couple of changes that went there that made adoption of Java 9 a little bit tougher. But then also a lot of small changes that went into 9 that were really there were just a lot in total, like small language changes, very minor ones though. But there were new APIs and lots of updated APIs, and for example, new tools and new like JShare, for example. And then we had what else? There was more stuff. Oh yeah, right. Multi-release jars. That's one thing I like to mention because that's
A
an
little bit
interesting thing that
about
got
it.
added in 9. Sorry.
As we touched module system, can we talk a little bit about it? Because we have a question. If there is use cases for Jigsaw somewhere
Yeah.
besides libraries and frameworks development.
Yeah. Sure. First of all, let me quickly finish that thought. So I think with 9 and then the new release cadence of every 6 months, Java was in a better position to just evolve. Not that much faster, actually. It's not like like the same amount of people roughly work on the same stuff. So it's not like Java tripled its development speed, but it just got a bit better. And then the regular releases made it easier to gather feedback on features. And so since then, I think really what modern Java means to me basically 9 and later. So everything that happens with the new release cadence and uses some of the new usability features, and specifically what's coming up with like Loom and Valhalla that you already mentioned. Yeah, regarding the module system. So I like the module system, but I know that puts me at somewhat of a minority. So take everything I say with a grain of salt. But it's interesting to see that I feel like most people think like, I'm working on an app, it feels like a feature for library developers, and sometimes library developers express the same thought but the other way around, like maybe it's more like for application developers. So the value I see in the multi-system is generally if you're managing a larger project that consists of more than just a single jar. So that this does more than just, like I pull in a small dependency and then, write a couple hundred lines of code. As soon as you start splitting up in several jars, or you have a deeper dependency tree, I think from that point on, the multi-system does start to make sense. If the app is very small, the effort is very small indeed. And yes, then the benefits are also small, but I think it's still worth it to, from the beginning, think about the structure, think about what do you want to expose outside a module, which is like strong encapsulation, which I think is maybe the most important feature of the module system. I think like I remember how often I was writing code and I was like, I want this class to be visible not just in the package, but also elsewhere in the jar, but please not to somebody else outside. I've been in the situation so often. And so to me, the value of the module system was immediately apparent. I can now finally do that. I can now finally have classes that are visible inside my entire jar, but nobody outside of it can touch it. And so strong encapsulation is definitely a very important one. And I mean, there are more smaller like downstream benefits, like you use it with JLink to create these runtime images or application images rather, that include your application code. There's a bunch more things that you can do, but really I think it should be seen as a tool to enforce a more modular structure. It doesn't make a code base modular. You still have to work to that. You still have to make sure that you cut a more code base in the right places, that you make sure that some things are a stable API that you want to expose within your project even. And to think those things through, that's not something the model system is going to do for you. But once you have done that, once you have thought those things through, then you can go back and say, okay, like now I'm going to put in the module descriptors, make clear boundaries between modules, make sure nothing happens accidentally. Like what happened a lot in a larger project that I used to work on was somebody had to implement a feature set. So, you have a bunch of stuff that is the actual feature set that is usable from outside that jar, from the rest of the project. But you have a bunch of other stuff that you need to implement it. But for necessity, they might also have been public. And then what happens a lot is that, other developers, they see that functionality that you just used as an implementation detail. And they're like, hey, I need that, or almost like that. So let me fiddle a little bit with it, and then I can start using it. And suddenly you had like a growth where things depended on one another that nobody really intended. Specifically, you start depending on internals of other jars that nobody really intended to be written like that. And now you can clearly say, I wrote this functionality. This is part of what's the public API of this feature that other parts of the same project can use. And then the rest is internal, meant only for within this jar. And I think that's a use case that, of course, cross jar boundaries is more important for libraries and frameworks that get reused a lot. But in a large code base where you can up with dozens or maybe even hundreds of your own jars in just one project, it's also very important. It also communicates intent very well. So I think, yeah, there's a lot of value in those situations.
Maybe a great example of exposing unnecessary classes is misconsafe, which is going to be duplicated for several releases in a row, but still is accessible.
Yeah, I mean, unsafe is like its own special story, right? Like it's not just you shouldn't use this. It's also like actually you can, because it has like a private constructor that you're not supposed to call. But if you use the right reflection, you can still do it. So that was really like a little bit of an arms race going on between the JDK team trying to hide it and everybody else trying to use it anyways. And I'm not even pointing fingers, right? The reason why unsafe was not just encapsulated as as it should have been by its name because it's in the Sun package. The reason why that happened was because for some of the users of unsafe, there is no publicly available API with the same performance characteristics. Often it's down to performance. It's very unsafe, hence the name. So that's why it's not great to use it. But there are certain use cases that you cannot, in a performant way, do otherwise, and that's why it got used. So, and that's why now slowly there's going to be replacements for these internal APIs, and slowly but surely, unsafe will basically become useless, because all of these features will have better, safer, and hopefully even more performant implementations. But I don't know the exact details on where we're at, but I think it will still take some years for all of this to unravel and for unsafe to go away.
You maybe are referring to Panama project, right?
Panama as well. Yeah, Panama's not the only thing, but yeah, of course, they're also doing stuff where In the past, when you had to manage off-heap memory, often unsafe would be the way to go. And now with the foreign memory API that Panama has introduced, like it's in preview, so it's an incubating API for a long time already, and it always gets
Mhm.
refined and it gets more crisper, is what the term that got used in an Inside Java podcast about that. And so yeah, Panama, for example, is going to take away some of the use cases from unsafe. Exactly.
Mhm.
And that's also,
We
by
have
the
a
way, where
number of
multi-release
questions
jars.
from
Sorry. That's also
we have a number of
where
questions
a
from
multi-release jars
attendees.
tie back into, which is if you're a library developer and you develop something the for the old unsafe, and now Panama comes out and you can use the new API, you can still ship a single jar that on the new Java version uses the new API, and the old Java version uses the old API, and this way you can, as somebody providing a library, but also maybe just a company internal utility, you can use multi-release jars to use safer and more reliable APIs where they are available, while using the old stuff on old versions where you still have to, and thus give a good migration path and be like, you can already use the new stuff, and then in a couple of years I'm going to drop the old stuff, and that way.
Yeah, thank you. We have a number of questions from the attendees, and the first one is pretty generic. Maybe you can highlight the changes in Java release cadence, um, because
Yeah.
there were changes. And
Yeah, right. So in the past, the release cadence was want to have a big usually there's a big feature in there like lambdas or the multi-system, but also we want to go for release every 2 years. And every developer knows that that's at odds. Like we want to have the big feature done, but also there's a strict timeline. Doesn't always work. Didn't work out that great. Like the multi-system Java 9 came out 3.5 years, I think, after Java 8. So yeah, it's like that it happened what is normal in software development. Things take longer, and then a lot of but it didn't go well because so much stuff was already done that could have been shipped earlier. And I think really that experience particularly really ingrained that look, this both of this, we need a big feature, but we also do it like every 2 years, where missing one release really hurts. Like you don't want to wait another 2 years, so you just like push this one out just like half a year, and then maybe we're done. So going to the new release cadence, which is every 6 months like clockwork. So it's, I don't know the specific algorithm that determines this, but it's, I think, like the second or third Tuesday in March and September, something like that, right? So it's always in the middle of March and the middle of September is when the new Java versions come out, and that clockwork is really helpful. It means 3 months before the release, the release branch, or it's a fork actually, but you can think of it as a release branch, is cut. And so everybody just develops their stuff, right? When Panama has something that is done, it merges it into main. When Valhalla or some simple API change, or maybe another language addition from Project Amber, when those things are done, they get merged into main. And then at some point, 3 months before the release branch gets cut, and everything else that then goes into main will just not be in the release. So the release can stabilize and be shipped. So that's like that clockwork really helped a lot. And if it hurts, do it faster. Work 100% here. Like the team often says internally that things got so much easier now that you don't have to bother with that anymore. You don't have you don't have to, like, it's not fiddly to plan ahead. You know when the release is going to be. When the release branch is cut. When the different release candidates come out. All of that in advance, and it's thus very easy to not waste time on discussing that and figuring that out. So that's really has been a boon to the Java development, I think.
And by the way, there is still change in the release cadence since Java 17. We do not wait now for 3 years. We will wait for 2 years for long-term support release. So the next LTS will be Java 21, right?
Yeah, so
Java
that's like
21st.
technically that's like it feels very related, but technically it isn't, because like the release cadence of Java, of the Java language specification, and of the JVM specification, and of the reference implementation which is the OpenJDK, all of that is something that exists within the OpenJDK project, within the community. And then of course in that community are individuals who contribute. Most of them are paid by companies, for example Oracle, but of course also by other companies. And this mostly OpenJDK is a community of individuals working on the OpenJDK, of course, funded by companies. And then the companies on the outside of that process, they then build their own support and contract models and whatever on top of that. And there, there's a wide variety of projects of companies doing that. So technically, every company can say, we give you LTS every 17th release or every prime number or whatever. Like everybody can come up with their own
Mhm.
idea of how to support this. But then again, of course, it still makes sense to align on a similar cadence. It just makes it easier for customers. It also makes it easier for the individual companies to maintain, because then there are shared branches in the OpenJDK and all of that. So there's a tendency to find one common denominator. And that used to be 3 years between 11 and 17. And then, maybe that's a bit
Mhm.
too long. Maybe that's a tad too long for adopting a faster cadence, because it turned out that many customers or companies using Java did in the end decide that they will go from LTS to LTS, which I find a bit sad. I don't think there can be good reasons for that, but I think more people could do it. I don't think those good reasons apply to as many companies as are sticking to that release cadence. But that's a different topic. Now the idea is, well, if they stick to LTS every 2 years, that's a bit easier for them. And also means if you start a new project and it's going to go into production next year, you can, maybe we can already, well, next year not, but if we start in the end of 2020, you could maybe already start on Java 19 and then guess, like, by the time it comes out, it's on 21. So it makes it a bit easier to plan for the next LTS and, piggyback on that one if you want to stick to LTS.
And by the way, what do you think? There is more than one company that develops JVM and releases it and provides, like Amazon, Azure, Google, and so on. And what do you think? Are they also aligned to the release cadence with LTS? I mean, what does it mean for them? Um, do they need to stick to LTS cadence?
Yeah, so technically, each of these companies can do whatever they want, right? But as I said earlier, there is like a tendency to align on a shared schedule. And I have to say, I don't know where that proposal is technically. So if I remember correctly, Mark Reinhold proposed this, not so much announced as proposed this, by the time Java 17 came out, I think during the same days, and proposed to change the LTS cadence, or said that Oracle is considering that. And then I think we're waiting for feedback from other companies. I have no idea where that process is, though. So maybe feedback was already provided and it's already settled. I can't really say. Maybe I should look into that. But I would guess that I think that it's fair to assume at this point that it's probably going to be 21. Then again, just waiting. Like, it's not that important probably right now because 17 just came out. So waiting for another, I don't know, half a year before before making a decision that is based on a 2-year versus 3-year LTS is probably still plenty of time. Right.
Mhm.
So yeah, I can tell. Like in the end, if you are using a certain JDK from a certain company, the things you could probably do is A, contact them and ask them about it, and B, decide what you think would be best for your project, and then find a company that gives you the support that you need. Support is also a vague term. Like, support doesn't always, like, what does support mean? Does support mean there's a bug fix will eventually show up, or does support mean there's somebody I can call in the middle of the night if my JVM crashes? So not the same level of support. So you should decide what level of support you need, what intervals do you need, and then who do you trust most to provide that, and then go looking for that company that fulfills those criteria.
Mhm. Okay. We have question from Ruslan about records. He wondered how to attach a builder to a record. What do you, so that you can shift from entity to DTO in the right way, and while sealed classes. Maybe we can start with the record. How to use builder in it.
Yeah, so that's actually a good point. So I don't have quite the builder issue myself, but I really like static factory methods. I use them a lot, specifically for like data-like stuff like records. So for example, the datetime classes, they all have these off methods, which you can like you give them a string and then you get back like a local datetime or something. I really like those static factory methods. And of course, you can add them to a record, but the constructor is still publicly visible. So it's a bit, well, so what's the point then? So that's something
Mhm.
that I encounter myself. And with builders, there's no there's no support there in any specific way. If you want to have a builder for record, what that means is you will probably ask your IDE of choice to generate the builder. I mean, you can type it by hand, but you don't have to, right? So you would have a record which has, like, let's say 3 components, and then you would generate a builder class that has 3 fields, 1 for each component, and then a setter method that returns the builder. And then in the end, you have a build method that just calls the record constructor. So you have to create all of that code, either type it yourself or have it generate by an IDE. And then still, the record constructor is still available. So was that really that much of a benefit? So it's like with the static factory methods, although the builder has more advantages than a static factory method. But with the static factory method, I actually gave up. I was like, okay, I'm done with records. Apparently, I'm going to use a constructor now. So there's that. So there's really no specific integration. You basically have to do the same things you would do for a regular class.
So you can just create a public static class within the class of the record, within the same file,
Yeah.
and do it manually. Just create manually the builder, right? But there is no automation for this process. Maybe some frameworks or libraries provide this. I'm not sure. Okay, we have a question.
There was a question about entity and DTOs, right?
Sorry?
There was a question about entities and DTOs, right? And records and how that works.
It's like a shift from entity to DTO, because you know, for entity, there is another question from the same also. Why sealed classes? And maybe I can rephrase it. What is use cases for sealed classes? Because you know, they just prohibit to create some inheritance, and it's again a kind of use cases for module system, for libraries, for frameworks developers. But what is used for regular developers?
Yes, so 100%, although that will require a certain change in perspective. So let's say you have a customer relationship management system, right, that you're maintaining. So you probably have a class that's called customer. And so then maybe you want to attach, maybe you want to you need to deal with the customer when writing invoices, or when logging them in, or when, I don't know, sending them emails. So there's probably plenty of ways, because it's a central class. That's the idea here, right? It's a central class that's essential for your entire system. So probably many parts of the system want to interact with it and do stuff with it. And that adds that introduces this problem that potentially there will be feature creep, that potentially you're going to start adding all of these methods to customer that don't really match one another. Yes, they're all related to the customer, but other than that, what has that sending an email with, you know, billing, creating an invoice, that's nothing to do with one another, right? They just end up on the same class in this hypothetical, because they all deal with the same class. So what you would do to avoid that would be usually to use the visitor pattern, to say, okay, look, we're going to have like just the customer class, which is just the core of the functionality I need. And then in the billing system, I'm going to write like a customer visitor that I can pass maybe to a list of customers, or, you know, because there can be other subclasses of customers maybe. And then it will know how to write an invoice for the customer, stuff like that. So a way to extend the functionality of a class without adding all the methods on the class is usually the visitor pattern. Now, the visitor pattern has its value, obviously, but it's not great. Like, it's very indirect. It's not easy to see what's going on, and it's a lot of extra machinery you have to set up to make it usable, or to use it. And what pattern matching and sealed classes, these really go together. What they can do is something you would not have done in the past, which is basically, well, if you give me a customer, and it can be one of these 3 subtypes, and I need to write a function that, you know, creates an invoice for customer, but, you know, depending on the subtype, I do something differently. I don't want to add the method to the customer interface. Instead of using a visitor pattern, what I can do now is I can just say, okay, switch over the type of the customer that I have. Now, in the past, you would not have done this, because like it feels wrong. It just feels wrong to assume, well, I know that the customer has these 3 subtypes, so let me just write an if-else chain. If it's this one, do X. If it's that one, do Y. Like, my skin crawls just thinking about it. But the thing is,
Mm-hmm.
with sealed classes, you know the subclasses, and also the compiler knows the subclasses. You express it clearly. You write sealed class or sealed interface customer permits ABC, and then you know only ABC are allowed as subclasses of customer, and then you can actually use that information to create a nice switch. You wouldn't use an if-else chain. Instead, you write switch over the customer. Case it's subclass A, do this. Case it's subclass B, do this. And then what you get for that also is a completeness check, because the compiler knows that there can only be ABC. So if you only list A and B, the compiler is like, wait, you're missing something. That's not right. So you have to list ABC or AB default, of course, that works as well. But you can decide to have their AB list case A, case B, case C. And if then in the future you add a third implementation and you would, or sorry, a fourth implementation of the interface, then you will get compile errors everywhere where you used to write just switch over the first three types. And that's something that the visitor pattern also does for you. The reason why you don't want to do the if-else chains and why you do want to use the visitor pattern in the past is because when you use the visitor pattern and you add another implementation, you have to go through a couple of steps that in the end will lead to compile errors in every visitor. And that's intentional. It forces you to go to every visitor and update it to deal with a new type. And the pattern matching with sealed classes will do the exact same thing. It will force you to go to every place where you switch over the type and then add that additional case. So what that really does is basically lift this thing we built with the way that the Java dispatches methods and in a couple of classes and interface you wrote to that, and we lifts that into the language and says, okay, what the visitor pattern really does is it switches over a number of types, and what sealed classes together with pattern matching now does is the same thing, but more elegantly, much shorter, I think much more readable. And while there will probably be some specific cases where the visitor pattern cannot just be removed, I think in most cases it will just be gone. Small asterisk, sometimes you use the
Mm-hmm.
visitor pattern to basically pass the functionality to a data structure, and that data structure will then iterate over its internals. So that part of visitor
Mm-hmm.
pattern is still useful, but I would expose that in a different way. For example, you can have a tree you call iterate and returns a stream of nodes. That, for example, then each node could be this class or that class. I wrote a long blog post about that and got a little bit of heat because I was like declaring the visitor pattern to be dead. Not
Mm-hmm.
everybody agreed. So that's my point of view. But I think it's safe to say that a lot of instances of the visitor pattern can be replaced by this.
I think your point is clear now, and it's a great example. I personally appreciate your answer. So yeah, sealed classes are going together with pattern matching, and it's for sure great illustration for this. We have a question from Sergey. Can Java be considered as a language for writing desktop applications? For example, port and GRE and show it along with project files into the installer. So what do you think? Java and desktop.
Yeah. So I mean the Java. I mean, so Swing. I don't know. I guess like AWT and Swing don't see a lot of development. I guess. I mean they're pretty mature as well, but specifically Swing. But I don't think it sees a lot of development. So if you feel like, well, I can't build the desktop app that I want with Swing, then it's probably not doesn't probably make sense to wait around for Swing to get the features that you're missing. I'm a little bit guessing here. I don't actually know how many people work on Swing, but I wouldn't be surprised if it's not many. JavaFX, I think, has a little bit more of a drive. It's generally more modern. It's more approachable. When I worked with it years ago, I actually liked it quite a lot. The reason I'm called NipaFX is the same FX as in JavaFX, by the way. So I did like it a bit working with it. It missed back then. I think I felt it missed or hurt. It had missed some features that you would have in Swing, but I also feel like JavaFX matured, so there is that. So it's not like you can't write desktop apps with Java. I don't know. Just still doesn't seem. I don't know how many new projects start. I know of several projects that have a client server structure, but the client is a thick client. It's like a Swing client that are moving towards just writing a regular Java backend and then have a JavaScript, HTML, CSS frontend. I know of two large projects, and I basically know of no other project. I know nobody who's like, well, we did like a front end backend split with with Java on the backend and HTML on the front end. I wish we would have used JavaFX or Swing. So I don't know. I think it really depends. Like when you know specific use case, I would really look into whether the Java desktop functionality provides what you need. But I think chances are like the common split between Java backend and like an HTML JavaScript front end is probably widely used for a good reason. So yeah.
I think besides the UI and UX frameworks, which are not, there is not much variety for Java at the moment. There is also another question that Java requires runtime. And if we're talking about desktop applications, you should ship your GRE together with your application. And there could be some licensing questions. And by the way, we can probably highlight the changes in licensing for Java. So starting Java 17, there is some change. Could you please highlight it to our
Yeah.
audience?
So first of all, I described earlier how there's the OpenJDK community, and then there's basically companies that are, well, of course, funding the people working on the OpenJDK, on the project, on the code base, are still separate entities. And what we discuss now is just for Oracle, right? So Oracle decided that the Oracle JDK is going to have a new license. So Oracle provides two JDKs. You can get the Oracle Open JDK, which is GPL licensed at jdk.javanet. You can download that. That's always the current version, and that's the thing that that's the Open JDK built from Oracle. If you find companies that
Yeah.
say we built the Open JDK, then I'm not gonna say exactly, but like in spirit at least, I think there should be bit for bit the same thing, like same license, and maybe some names are different somewhere. But most
Mhm.
like projects building the Open JDK do exactly the same thing that happens on JDK JavaNet, which is the Open JDK built by Oracle. So there's that, and it's GPL license, so you can do whatever you want with it. So that's and class path exception, of course. And then Oracle had in the past, you had to have like a Java SE subscription to use Oracle JDK in production. And now Oracle has a new license where you can use the Oracle JDK. So that's not on JDK JavaNet. That's oracle.com/ probably Java something. That's where you can get that one. And that now is for free for the LT. Sorry, it's for free in production, I think, for all the versions. And I definitely know that for the LTS versions, it's going to be free for 3 years. So the idea is you can pick up the Java 17, the Oracle JDK 17 build, and use it for 3 years in production for free. And then after 2 years, probably 21 comes out, which is the next LTS. And then you have like a 1 year overlap to change. Now it's free to use in production, but I think some limitation when it comes to like reshipping it in a sold project. Sold product.
Mhm.
And I'm really not a lawyer, so if that's an important decision for your project, do check with a licensed expert, which is once again not me. But you asked about shipping with the JRE, right? So the Java runtime environment is not really a concept anymore. That ended with Java 9. So you cannot find easy downloads of that either. You can create your own, since everything in Java 9, at least within the JDK, is a module. It's really easy for you
Mhm.
to just create the runtime image that you need. You can either build the entire thing, which contains the compiler and the Java doc too, which is probably not what you want for a customer app. If your app is fully modularized, it's really easy. You just say you can find out what your dependencies are very easily and then just create that. If your app is not modularized, you have to do a little bit more work. You can use tools like JDEPs and figure out what your dependencies on the JDK are. And then you can figure, okay, so it's these 5 modules. You pick up JLink, you tell it, build me a runtime image that contains these 5 modules. And then JLink isn't stupid. It puts in all the dependencies of those modules as well. So, they actually work. And then in the end, you get a runtime image that contains the minimum amount of modules that work to support your application. And what you can do then is you can then ship that to your customers. Or you can include your own code. If it's modules, it's fairly simple. If it's not, you have to fiddle a bit. Now there's also JPackage, which I think was introduced in 14, which allows you to create operating system specific installers. So you can give people like an MSI file on Windows, or I don't know the Mac stuff, but yeah. So you can give people like specific installers that are like native to the operating system. And So that would be, I think, the common way to ship that. So really, like, do not rely anymore on your customers having a JRE or a JDK installed. This has a big upside that you can now control which Java version your customer uses. But it also comes a little bit with a downside, because if you ship your customer a Java 17.0.1 release, and then 17.02 comes out, has a security fix, you should then make sure to deliver your app again with the new Java version, right? Because you don't want to have your customers sit on an outdated version running your app on a JRE that has potential security risks. So while it has like the big upside that you control the JDK, it has the downside that now you must JDK that you ship.
Yeah, and I think also about another option. Maybe compile your application with Graal VM into native image, right? So it could be shipped without requirement to have a GRE on the machine.
Yeah, like if you use Graal to create a native image, assuming that all your dependencies play ball and you don't use too much fancy, like bytecode manipulation at runtime, then yeah, you also get an executable which is operating system specific, and it just runs, right? You don't need any extra, and it runs.
Yeah.
And specifically, it boots like super fast. Like if you want to write small tools in Java, which another feature, by the way, that was added in Java 11, which is really cool. You can now take a single source file and just throw it at the Java command, at the Java launcher. So without having to compile it first, you give it to the Java launcher, it will compile it in memory and then run it, which is great, because if you're one-trick pony like me who can only do Java, well, now I can do a little bit of like the web stuff, but I'm still not great with like C, Python, or Bash. So what I can do now is I can write a script that does some small things on my system, like just in Java, which is great, because Java now with streams and the file IO stuff that got added, like it has really some handy methods that makes it really cool and fairly straightforward, specifically if you know it already, to write a well-to-maintain script that does a bunch of things on your file system, as I said, or whatever. And so you can write that in Java and just throw it at the Java launcher. And if you then figure out, well, the script should just run a couple milliseconds and not take like a couple hundred to boot up the JVM, then you can take it to Graal and create a native image out of it, and then you actually get like an executable on your operating system that boots like this. And then I think it's a JBang that makes all of this process a bit easier. That also includes the Graal. So the JBang, by the way, unlike the other projects that I mentioned so far, are not part of the OpenJDK. That's done by the community. I think his first name is Max, but I think I forgot his second name. I hope I'm right with that. Anyway, JBang, great project. Check it out. While you're at it, by the way, check out SDK Man, which is also a great project. So with JBang, you can easily start writing these scripts, and when you're done, you throw it at Graal, you get a native image, and they launch really fast. So I think really that's also part of what modern Java is. It's not just, which is already quite a big chunk of what code is out there, but it's not just a language for Java backends. It works in education, it works for scripting, it works for small projects. It's not something that you pull out only when you have to write like a million-line a server backend. Like, it also makes sense in different situations. It's really versatile. It's becoming more versatile with Project Panama, making it easier to interact safely and fast with native code, makes it much more viable in the machine learning space, maybe in the embedded space too. I don't know that very well, but that's surely something that could be considered. And then it works great. Like Valhalla works great with it as well. We have these value types that really integrate well with Panama, because you're probably going to interact with systems that have different primitives than Java has. And nowadays, you would always map that to the few Java primitives that you have, and you can't really make use of something very specific, like an int that is only positive numbers, right? So there's like specifically machine learning, as far as I understand, there's a lot of primitives that are very specific to that space. And at the moment in Java, you cannot really map efficiently to other small data structures or small primitives, but Valhalla will make that possible. So that's also, it opens up a whole new field of things where you can maybe write like the same high performance machine learning code, just stick to this example, with Valhalla, or you can rely on existing implementation, use Panama, use the foreign function interface to very simply and, as I said, efficiently interact with it, and then use Valhalla to create all of these specific primitives that you need to interact with that without a loss of performance where you map everything to a long just because you don't have another type available. So I really think like the future in that sense is bright, and I think the last half of the 10s, so of the recent decade, was the time that Java picked up speed again. But I really think like the biggest changes on the surface level will be what comes next. Will probably be Valhalla. That also opens up Java to more use cases. I mean, text blocks are amazing. Don't get me wrong, but with text blocks, you're not going to do something that you didn't do before. You do the same thing, just
Mhm.
it's easier, more readable, more maintainable. That's an incremental improvement. But I really think that Loom,
Yeah.
Valhalla, Panama, they will open up entire new use cases for Java. Will make it much more versatile than it already is.
Yeah, and talking about Valhalla, we actually are waiting for value types whenever they will be named, and there will be a second phase for the implementation for them. As far as I know, there should be something like collections of such types. What do you know about this?
Yeah, so I mean, Valhalla is huge, right? Like, there's like it happens on so many different levels. So in the language, you want to be able to say, well, this is my own kind of int, like the int that only has positive numbers, or this is my own point class that has an int x and an int y coordinate. But I really want to treat it like a primitive. Like you could think of that for currency amounts or for just general units like lengths and everything, right? You don't want to have like, well, what you want to have is you want to have the abstraction of a class, which is public class length, which has like a unit and the amount of length. But you also would actually prefer to have the performance of a primitive, because in the end a length is really just a number. So if you want to have that performance, then creating a full-blown class, that's like a trade-off. You have to decide what is more important. I would always say go with the abstraction first, but if you figure out later that it's not performant enough, then you have to rip it out and write code that is not the code you wanted to write. It's not the most maintainable code that you had in mind, and that's of course a downside.
Mm-hmm.
And so on the language level, you want to have Valhalla there to be able, like, don't worry, you can now create your value class that looks like a primitive and acts like a primitive. And then it reaches all the way down to the JVM, because then you want to have actually those performance improvements, right? Now you want to make sure you want to have the benefit that your point actually does behave more like an int than like an integer, right? Like a capital I wrapper class integer. So there's that
And,
aspect.
and, and
And then there's also the part about generics, which is probably where you went, right? Like if you have an array list of point, of upper class point, then you have an array list of just pointers pointing to your instances. Probably
Mhm.
point is a bad example because of the pointer, but you get my point. Wait. Yeah, just making it
Yeah.
worse. New example, you have an array list of integer. What you really have is an array with pointers to all the integer instances all over memory, which is not great for a ton of reasons.
Yeah.
Those are performance reasons, don't get me wrong, which are always not the most important part, but they can become quite important down the line. So that's not great. You don't want to have that. What you would like to do is have an array list of int, which just has like the integer ints back to back, just the 32-bit integers in that array, no pointers anywhere.
Yeah. To be
And we don't
referenced
have that.
by value.
Yeah, exactly. And we don't have that. And that hurts, but it doesn't hurt that much, because really, do you want to have an array list of integer? I mean, like, why though? It's not like integer is a great abstraction. I think I rarely want to actually have an array list of integer. But if we now start creating points, and I don't know, what are all our own abstractions as values, now suddenly the use case for putting primitives into generics increases a lot. And now would really be bad if the JVM would be like, you know what, you can create a value class that is a point, and in how we treat it like a primitive, and you get all performance benefits. Unless you mix with generics, it immediately falls apart. I mean, that's a bad story, right? Because we always want to use generics to make the code more maintainable, more usable, and more reusable. So it will be really hard to avoid generics entirely, just for that. And so that means we want to have the situation where you can actually create an array list of int and then have it as an integer array, and the same with the array list of point, which just embeds the xy coordinates of your point into the array. And that's something that's going to come after. So first, it's going to surface in the language, and then that opens up freedom for the JVM to optimize your code. And then those optimizations will probably take a bit of time. And then the second part that surfaces in the language is the generics part, and then that will show up in the JVM as performance
Mhm.
improvements. So we can expect to first be able to declare these things with basically like performance promises down the line that will then probably materialize over many releases. Like every Java release gets a bit faster for this reason or another. GC gets improved, the JVM as a whole gets improved. So there's always these gains. And specifically when something is new, initially the gains are the largest, right? Like the garbage collectors, I mean, they still see improvement, but they're also like years, partially decades old um, concepts and code. So of course, a lot of potential has already like been pressed out of it. But when lambdas were new, for example, there was a big change improvement in performance in the first Java 8 minor releases, and probably I would guess something similar will happen here. That the value types that you can use in the language will open up performance improvements in the JVM. That will then probably be initially there will be I guess more improvements, but then there will keep coming improvements, just like probably on a smaller scale. Just because at least that's how I understand it. Maybe I'm wrong. Maybe Brian is watching this and Brian gets it and he's like, no, you're wrong. We'll just get all the performance improvements at the first release. I would personally be surprised. But yeah, the JVM details are complex and I'm not expert in that at all. So take what I just said about performance with a grain of salt.
Mhm. Nikolai, we are a bit limited with time, so we will have time just for 2 more questions. I'd like to select the one which is about garbage collector, about new Java garbage collector. Can you highlight some insights about it? What does it provide to the developers?
Yeah, not really. So
It's actually
first of all,
not new since Java 17, yeah, but
yeah. Yeah, so I mean, there is ZGC out there. There's Shenandoah out there. There is G1. So there are a bunch of garbage collectors being actively worked on. Parallel collector also sees improvements all the time, and to my understanding, a fair comparison is if you do batch work, like if you don't mind pause times, if all you want to have is like the most throughput you can have, I think Parallel Collector is still your best choice because it's just like it doesn't care. It can pause the world for like 10 seconds and do its thing. And if you do like a batch work every night, running across like a ton of database stuff and pulling things up, who cares? If you want to have a web
Yeah.
backend, you probably don't want your 99 percentile wait time to be 10 seconds because Parallel Collector was like, I got to do this now. So that's where these other collectors come in. And yeah, like that's really all I can say about that. There has been a blog post. Maybe we can share that after the show by now I don't even come up with the name. Let me at least look up the name because that was a great one. Yeah, Stefan Johansson from Oracle as well. He wrote a blog post about is there a chat here? Wait, let me see. I don't. Oh, there is one. Look, I'm just going to write in the chat here. Maybe you can get it to the viewers. He wrote one blog post about the performance improvements between Java 8, 11, and 17 in Parallel GC and G1 and in ZGC. And what you see there is things get better. That's really all. And I think for the average developer, it's probably not that important, but somebody on the team should probably know a bit more about garbage collection and make sure that you pick the garbage collector that best fits your project. So you have like a 2-person team, you have 50-50 chance that that's going to be you. But if you work like on a larger team, not everybody has to be a GC expert. But somebody probably should be on a larger team to make sure that, as I said, that you run the GC that makes most sense. It would be great if you have like performance benchmark suite that you can just like run a battery of tests and then get some certain benchmarks out, like what is your 99 percentile latency and all of that, and then just try with different garbage collectors and figure out what works best for you. So if you have that chance, that can be a very healthy exploration. It can make your app more performant for the customer. Maybe if you're running in the cloud, it could lead to the fact that maybe in that situation, like because the pause times are slower, at least like in the extreme cases, maybe you can even shut down certain instances and save money. It's actually a good chance that with newer Java versions, you can do that anyway, because they also get more conservative on memory consumption. Like generally speaking, below the surface of the language and the API, there's also a ton of improvements going on. They're more incremental, but they do add up. And specifically between 8 and 11 and 11 and 17, you can really see benefits of that. Then there's also JFR event streaming, which makes it easier to observe what's going on the profile your application. So there's a lot of tools that have been added that should give you just performance improvements on the one hand. And if you're running in the cloud or even on your own premise, that often translate into saving money, right? So if you have like 10% less memory consumption because of a Java update, hey, good chance that you can save 10% of the money on your cloud bill. So that's definitely worth exploring as well. So really, I really can only recommend try to update to the newest Java version. Go to, if you're still on 8, go to 11. If you've done that, go to 17. And if you are on 17, I would recommend trying 18. I think there's a good chance that you can stick from 18 all the way to 21 without having to go back. I mean, that's a horrible case to have to downgrade. But I don't think that like the chances that happens to your project are very, very slim. Like there's not like Oracle just randomly goes with a shotgun through the code base killing APIs. There's like finalization, for example, is currently being deprecated for Movement Security Manager. You should be aware of those things. And if you are, and you think like that's not going to be a problem for you, I see no reason not to stick with each individual release as it comes out. It always gives you the best JVM. It gives you the newest API and language features, which make your team hopefully more productive. And it makes everything smoother, right? Like if it hurts, do it more often. Doing a big update every 3 years is probably more trouble than doing a small update every 6 months. But then, of course, like if you have an application server, for example, that they might stick to LTS releases. So I'm not saying like, I said there's no reason not to do it. I want to say there's no reason not to try it. Like if your dependencies don't play ball, then there's nothing you can do, right? But I think you should really carefully consider it and give it a real chance.
Nikolai, I would be glad to speak with you for a longer time. And there is a lot of questions left unanswered yet, unfortunately, but we're running out of time. So, Nikolai, thank you for the amazing Fireside chat. Your experience is unbelievable.
Thank you, Artem.
Thank
Thank you for having me and for the great moderation. By the way, if the audience wants to reach me, there's my website is nipafx.dev, and there's a bunch of links up there to Twitter, to a Discord. Reach out to me in a public forum, and I gladly see whether I can help you out, answer any questions that were left unanswered, give you links to if something I mentioned maybe. So yeah, we'll always run out of time sooner or later. But if you can find me elsewhere, maybe at Java Zone in next week. If you can find me elsewhere, just flag me down, ping me, talk to me. I'm always glad to be helpful, or just to talk.
Thank you, Nikolai. Yeah.
Thank you as well, Artem. Bye.
Yeah. Have a great day.